Yo guys, what's going on? Emperor here. Today I'm here with the FPS tutorial, view model stuff, animations, gun movement, like the swaying and stuff. Next video we're gonna be covering like the damage, the projectiles, and all that. So if you're not interested in just the view model stuff, wait for the next one, which will actually cover raycasting, all that interesting stuff. But for this one, it's just gonna be pure old camera C-frame manipulation so that we get a very smooth looking view model so that it looks realistic when we sway our camera and stuff. I'll also be going over just some basic things about what you need to make a view model. Let's get right into it. First thing you want to do is actually have a model for the view model. For me at least, this was the model that I used. It's like the R15 arms, and then I made my own custom gun jointed to the primary part of the view model arms. The primary part is basically like where your camera should be. So like if I were to go into my arms right now, like this is probably what I would want the game to look like. Something like this. As you can see, like the gun is kind of blocking everything, but that's fine because this is the way it's supposed to be. The gun should be jointed to the primary part, not like the hand or anything, because when you animate it in like the animation editor or something, if you move the hand, then the gun will move as well, regardless of where you're like actually trying to position the gun. Let me show you an example. The way I did it right now is so that I can easily animate. The way this animation editor works is I can take the gun and I can move it, right? And I can position it. And if I move the arms and stuff, the gun doesn't move. And this is intentional because I don't want the gun to move every time my arm moves. I highly recommend you to just joint the gun to the primary part and not any of the other parts. I'll give you guys this model and I'll tell you what you can change to change the gun model. The aim part is basically where the ADS should be. It's just like right over here. This is what the ADS will look like. The fire part is where the bullets are gonna come out from. I have it like kind of in the center. And the handle is like what the actual primary part, I guess, of the gun, and you weld that basically to the primary part of the view model. To change what the gun looks like, you just want to modify the positions of the aim part, the fire part, and handle, and you weld it all to the handle. And also keep everything unanchored except for the primary. The primary has to be anchored. And also, I have got a animation controller in here, and that is so I can animate the object. So you can drag your view model over to replicated storage. You're not gonna need it. Another thing that we're gonna need is this thing called the spring module. So this is the spring model that I'm gonna be using, and it just helps us move objects in like a spring-like manner. I'm gonna put that in replicated storage as well. Let's get started. First, we're gonna define a bunch of variables. It's kind of like the classic variables that I'm gonna use. Couple services. We're gonna need the run service and user input service, as also the replicated storage. In the future, we're gonna use the GUI service and the tween service. So just get all of those. You don't need these two for now, I'm pretty sure, but for next video, we probably will be using those. Local spring module equals replicated storage dot, or actually require replicated storage dot spring module. Alright, now we have our spring module. We're gonna need to set up the view model so that it moves around with our camera. So view model equals game.replicated storage dot view model clone. Also, one thing that you should note is that I'm gonna manually make the joint. I'm gonna remove this here. That was just to show you that it is animatable. And I'm gonna be actually doing the setup of the joint in script because that usually is better. So view model equals that, and then I'm gonna parent the view model to the camera. For the gun model, that's game or replicated storage. I don't know why I used game.replicated storage there, my bad. So we use replicated storage dot. I called it awesome gun because it looks so goofy, but yeah. And the parent of that was is equal to the view model because we want it to be inside the view model. And then we're gonna basically weld the view model. We're gonna make a joint, and then let's put the name of the joint. I think I just named it motor 60, so you don't really need that part. And then part 0 is going to be Viewmodel.primary, right? And then part 1 is GunModel.handle, and the parent is going to be GunModel.handle. For my gun at least, I had to offset the gun a little bit, offset the weld so that it looks kind of right. So it was joint.c1, I think? Yeah, is equal to this. Okay, so that should all be set up now. The gun should be set up. Now we want to actually see the gun, right? So I'm gonna do render service or run service dot render stepped, or actually we're gonna use the other function. I'm going to show you guys something cool. Run service has a method called bind to render step, and we can give it a name. This is the thing, this is the name of the function, I'm pretty sure. And the priority, I'll just set it as 301, which is basically the camera's priority plus 1. And then function, and then delta time. Delta time is the amount of time that happens between each frame, and this basically runs every single frame. Now essentially we want to pivot the view model to the camera C-frame. That's what we're gonna do. We're gonna pivot it to the camera C-frame, and yeah. I did the brackets, the parentheses like this because there's gonna be a lot of stuff that we're gonna be adding in. A lot of multiplication that's gonna be happening, so we're gonna keep it clean like that. So I'm gonna play the game and let's see what happens. Wow, okay. So I've got the gun stuck like on top of my head or something. Doesn't look right, obviously. And the reason why is because we don't have an animation. As you saw earlier, I was able to animate it. If you want a cheat method of doing this without having the actual rig, the best way to do that is just make the gun model and the view model, and then do the code weld, and then to get the actual model, go to the camera, just copy it from there, because that's the actual model. So I'm gonna paste the actual model in here and let's see if it works. Yeah, it's right here. And I'm gonna use the animation editor, and I'm gonna load in one of the animations that I made for this. So here's the animation that I made for the idle. Remember, the primary is where the camera is going to be. Let me make it non-transparent, and you should be able to see it. Oh wait, that's the wrong one. This is the one. Now, if I put my face in here, you'll see that I was right. It's basically right here. That's where the camera is. Let me play the animation. Now, that's what it's gonna look like. So I have the animation ID and everything now, and I wanna play it. Let's play the animation. So, local idle animation equals, alright, let's do an animation table, just to be a little bit more advanced. Animations equals that, and then idle equals view model dot animation controller dot animator load animation replicate storage dot idle, and then let's just play animations dot idle play. Alright, now whenever we play the game, wow, I've got my gun now, and it's welded here. It doesn't move, and it looks really lifeless, so this is where the spring module comes into play. The first instance of this that we're going to do is using mouse delta, and we're going to set up a mouse sway spring. I'm going to put all the springs under here. Here's the mouse sway spring. Okay, I copied it over, it's kind of wrong. Instead of this, put vector3.new. So go mouse delta, we're changing the mouse position, is equal to UIS get mouse delta. And we're going to be adding velocity to our mouse sway. And the way we do that is simply using this. We take the mouse delta.x divided by 450, which is the rooted value. You should probably just multiply by delta time, honestly. It should give us a little bit of just like smooth springing. We have to actually update the camera C-frame like this. This doesn't do anything in itself, it just gives us a value basically. We need to multiply the camera C-frame by the negative mouse sway position at x, and then mouse sway's position on the y-axis. And we're gonna put the x on the y on the z. And the reason for that is because C-frame and vector 3, they kind of operate differently. The x-axis on the C-frame would be rotating up and down. Meanwhile, the y-axis for C-frame is moving to like in a side-by-side basically. But on vector 3 is only positioning, so to move something up is on the y-axis, to move something forward is on the z-axis. Basically, they're different in how they work. So let's play it and let's see if we can notice anything. You'll see that when I load into the game and I move my mouse, you'll see that my gun kind of like sways a little. It looks really cool, and it's like natural. Because when I swing around my arms, they don't like just stick to the camera, they kind of bounce, kind of shake back and forth a little when I stop moving. Next, we are going to add some movement sway whenever we move, just like in general. So for this, I'm going to use a little function, basically return a sine value, and it's called get bobbing, and the parameters are addition, speed, modifier, and basically just returns a value part of a sine function. Springs over here, I have this spring. Let me add a new one. I'm gonna call this spring movement spring, and it's nearly gonna be the same thing, except it's gonna have 0.4 as the dampener instead of 0.5. Alright, now inside for the movement sway, we're gonna use the get bobbing function here. So local movement sway amount equals vector3.new get bobbing, and then these are just the numbers that I used. You can change these numbers however you like. If you know how a sine wave works, this should be easy. If not, go search it up. Sine waves are pretty easy to understand. It's just like waves that are infinitely repeating based on an x value, and in this case, the x value we're using is the time, so it's constantly updating and just kind of swaying around. Let's increase the movement sway's velocity by this value. Movement sway amount divided by 25 multiplied by delta time times 60, and then multiplied by humanoid root part assembly linear velocity dot magnitude. Basically, it just detects if we're it just changes this value by the movement sway amount, which is like in a repeating order that like cycles through being low and being high, and then we multiply it by how fast we're moving. So let's update the angle here. We're just gonna use the movement sway. We're gonna multiply by, oops, my bad. Keep on copying the wrong stuff. We're gonna multiply again by another angle, so we're gonna change the angle by that much. And then we're gonna change the angle again using we're gonna actually just change the C-frame actually. So this would be the position. And you can see this would change the position of it, and honestly, any change to position should probably go before change an angle. It's just how it works a lot of the time. So let's do it like that. I don't know why this really wants me to indent like this. It doesn't make any sense to me. So let's play it and let's see what happens. It should be pretty noticeable. I'm gonna start moving, and you can see my arms kind of move around. Now, for this video, the last thing we're gonna be doing is the aiming. So as I said before, there's an aim part, a position or a C-frame that holds a location where the camera should look through, and we're just gonna move the entire view model so that that location matches up with the camera's location. So it basically looks like we moved the gun to where our camera is supposed to be. And with that, it's just some C-frame math, and we're also going to use the user input service to detect if we're aiming. So uis.input began connect function. The two values in here is going to be input and game process event, and if input user input type equals user input type dot mouse button 2, and we're gonna do something. We're gonna copy all this again. Input ended, and then right. Now I'm gonna add a state, like a status, to the gun. Local aiming equals false. We're not aiming right now, but whenever we're holding this down, aiming is true. And in here, the aiming is false, right? When we're right-clicking, we aim. When we let go, we stop aiming. It's pretty simple, right? Now within here, we're gonna give a C-frame offset, and we're actually gonna use lerp. Lerp is basically linear interpolation, and we just move something to a percentage of from a position to a position. So I'll show you guys what that means in just a second. Okay, so if we are currently aiming, then do this. Else we want it. Else we do something else, right? And basically, we're going to create a C-frame offset. So local aiming CF or something. And we're gonna set this to like nothing because we don't want anything to be offset when we're not aiming, right? We're gonna set this C-frame offset so aiming CF is equal to let's do aim CF lerp and then aim CF to the oh wait, my bad. So this would be the gun models aim part dot C frame, and then we need to make this relative to our view model because the gun is part of the view model and we're going to be moving the view model. So we're going to do it like this, and then this would be the percentage that we want it to move every frame. If you do something really high like 0.9, it'll be almost instant, but if you do something low like 0.1, it'll be kind of slow. And I'll show you guys that in just a second. Now I'm gonna copy this here, and when we're not, then this offset should just be equal to C-frame nothing, basically. You'll see that, oop, is it too low? I think it is too low. Oh right, no, I didn't multiply this. Okay, yeah, make sure you multiply by your aim CF. And since this is a position, I'd probably put it up here. See, there, gun is normal, and then oh, we've moved our camera to the aim CF. It's really slow, and that's because we're moving 0.1 of the distance every time. If we were to change that to 0.3 or something, so 30% of the distance, it will be a lot faster. And you see, it is a lot faster, right? So that's it for this video. We set up the arms, they sway, they move around when we jump, they aim, and they still move around when we aim. And I'll be doing all the server stuff and some of the other features for an FPS game in the next video. Let me know if you guys like this video. It's a little bit different than what I usually do, but yeah, I'll see you guys in the next one. Make sure you guys subscribe, like the video.